All right, we're going to continue with drill project 1. Last class, we left off where we created the levels, we created the solid model, and we created the wireframe from solid. If I go back to the project page, I'm looking at the steps that we were supposed to be following, and I noticed that I skipped step 9. It says use the bounding box tool to create the solid representation of the material. So what the material is going to be the part before we drill any of the holes in it. If I go back to the drawing, let's see here. The part measures 3 by 2 by 0.188. We're going to approach this particular project as if the material was given to us at the correct dimensions, 3 inches by 2 inches by 0.188. And we're just writing a program to drill a pilot and drill the holes all the way through the part. So the material representation that I create is going to measure 3 by 2 by 0.188. And because I have a model on my screen that already has those basic dimensions, I'm going to use the bounding box tool to create my material representation. To do that, I'm going to start by creating or making the material level the active level. Anything we create gets placed on the active level. It also takes on the current color. And we're going to create a solid representation of our material. And I'm going to want to change up the color so it doesn't match what's currently the color that's currently assigned to my solid model. So I'm thinking I'm going to use this burgundy color right here. I'll make my material this color. That way I have some contrast, or I'll be able to differentiate between the solid model that represents the part and the solid model that represents the material. So I changed my solid color and the material level is currently active. I'm now going to go to the wireframe tab and we're going to use a tool called bounding box. Click on bounding box. Mastercam is prompting us to select one or more entities or use Control-A to select all. In this particular case, because my model has the same dimensions as the material that it's going to be machined from, I'm going to use Control-A. So on my keyboard, I'll type in or I'll select Control-A. Everything becomes selected. I'll select End Selection. And now if you look in the parameters for the bounding box tool, you'll see that the size of the bounding box that it wants to create measures 3 by 2 by 0.188. It's basically creating an envelope around all the selected items. So this is the correct size. I'll scroll down and where it says create geometry, I do not want to create lines and arcs. I want to create a solid model or solids. So all I did is select everything on my screen. I'm double checking the dimensions that it's going to build this to. Where it says create geometry, I deselected lines and arcs and I selected solids. From here, I'll select OK to exit the tool. And you can now see a 3 by 2 by 0.188 rectangular shape overlaying our part. And that's going to be our material representation. If I make the solid model level invisible and I make the wireframe from solid level invisible, all you're seeing on my screen is a solid representation of the material prior to the holes being drilled in it. For now, I'll make the solid model visible. I'll make the wireframe from solid visible. I'll make the wireframe from solid the active level, and I can turn the material level off or make it invisible. We'll reference it here in a minute, but for the time being, I just want you guys to be able to see the difference between the solid model that represents the material and the solid model that represents our part. So from here, I'll save my work again. I'll go back to the project page. And if I look at all of the instructions for modeling up the part, that completes everything that I needed to do, steps 1 through 10, under modeling drill project 1. So I backtracked a little bit and I had to finish up where I missed a step. So with that said, go back into Mastercam. I'm now ready to move on and start creating tool paths. If I go to the project page, I'm moving on to the next set of instructions where it says creating toolpaths, drill project 1. And before I go into creating the toolpaths, I got a video that I'd like for you guys to watch. And there's some additional items that don't really relate to what we're doing tonight, but there are some examples of drilling of pilots and drilling holes on a CNC machine. And we're going to write a program. We're going to use Mastercam to write a program to tell a machine to do what we're seeing in this video. Not exactly what we're doing, not exactly what's being done in this video, but something very similar to it. So I'll select play. I can maximize the video. I'm actually going to turn this the sound down in the video. Actually, and this video is probably 10 plus years old, but it gives us some examples of drilling operations. Okay, so on that video, there were 3 separate tools doing 3 separate things. There was a spot drill, there was what they referred to as a jobber drill, and what they referred to as a screw machine drill. And what we're going to do tonight is we're going to drill these 16 holes, and we're going to do it in 2 steps, 2 operations. We're going to create a pilot with what I refer to as a spot drill, and then we're going to drill through with a drill that has the correct diameter for the hole that's being called out in the blueprint. And what I mean by that is these holes, they measure 0.201 in diameter, and we're actually going to use a drill that measures with the same diameter. The reason we create a pilot is because these longer length drills, when they come into contact with the surface that they're drilling into, they have a tendency to wander a little bit. And what these pilots do, or what these spotting drilled holes do, is they help guide the drill so there's less wandering and you're less likely to drill an out of shape or an out of round hole or an oversized hole. Does that make sense?
Yes.
Yes.
Nice. So we're going to use 2 separate drilling operations, 2 separate tools to create these 16 holes. So from here, we'll go down to the instructions for creating the toolpaths. Step 1, make the toolpaths manager visible and import a machine definition. So let's do that. We'll go back in the Mastercam. We'll need to make the toolpath manager visible. I currently have the levels manager visible. I also have the solids accessible. Now it's visible. I have the planes manager and I have the levels manager. To access the toolpath manager, go to the view tab. And then inside the managers section, you'll see toolpaths. Select it. And when it's blue, it becomes visible on the left-hand side of your screen. My toolpath manager is currently empty. So I've got this blank space. We're going to start adding some stuff to it here in a minute. And then I have some tools that are available to me inside of the toolpath manager. We're going to start by bringing in a machine definition. And a machine definition, the one that we're going to bring in is generic because we're using the home learning edition of the software. But when you're working for somebody, you're going to have machine definitions specific to the machines that are in your machine shop. At our school or in our machine shop, we have Fidel machines and we have Haas machines. And we'll use a machine definition specific to the different tool manufacturers or machine tool manufacturers, I should say. So tonight, we're just going to use a generic machine definition. Those should be available to you on your home learning edition of the software. To bring in a machine definition, you're going to go to machine. So next to the view tab, you'll see machine. On the far left side, you've got machine type. And what we're interested in is the mill. Expand the mill And I've got two separate machine definitions visible. You might just have the default available to you. So what you can do is go to manage list. And your dialog box probably looks like this: machine definition, menu management. I've only got two available to me. Once again, this is the home learning edition of the software. If you purchase Mastercam, you're going to have a bunch of machine definitions by default, and they will even customize them for your machine. So in this particular class, everything we machine will be in inches. So let's add the inch machine definition to this field. To do that, select mil default.mcam.tac/mmd. Do not use the mm.mcam. This is the metric version. This is the inch version. So we're selecting mil default.mcam.tac/mmd. Select add. Once it's added to this field, it becomes visible from the drop-down menu over here. So I added it to here. From here, I'll select OK. And now when I go to mil, you should see that machine definition. Once you see it, select it. And now we have a machine definition in our toolpath manager. How's everyone doing with that?
Could you show where that definition pop-up was, where you clicked on first?
Yeah, so if you go to machine right here, and you go to mil, you see where it says manage list at the very bottom of this drop-down menu? Select that, and chances are you've got two machine definitions available to you in this field. Select the, let's do this. Select the one that says .mcam.tac/mmd, not the mm.mcam.tac/mmd. This is metric. This is the one that we want available to us from this drop-down menu. So select the bottom one, select add, select OK. And now when you go to mil, you should have the default, and then you should also have the inch version of the machine definition available to you here. Click on this, and then it'll be added to your toolpath manager. Did that help, Brian?
Yeah, thanks.
You're welcome. Okay, so from here, what we're going to do, I want you to go to File, and then I want you to go to Project Manager. Click on Project Manager and the project file folder. This is the job folder that we created and saved our Mastercam file to. Anytime you create a job or anytime you're working on a project, you're going to want to keep your work organized. You're going to create a job folder. And wherever you go to work, they're probably going to have some type of standard. You're going to want to follow that. For this class, I recommend that you create a folder for the class, MACT 160. And then inside that folder, create a folder for each project that we work on. We're working on drill project 1, and we're going to save this Mastercam file to that folder. So we've done that. We did that last class, and the project file folder, this is the working folder. This is the folder where Mastercam is saved to. Well, I'd also like the NC files and NCI files saved to this location. So that's what I'm doing by checking these two boxes. We're going to create these down the road. And this is telling Mastercam when we create them, we want them saved to this location. So I check them here, and then I'll select OK. Once you do that, select the back button, and that brings you back into Mastercam. We're now going to make some changes to the default settings of this default machine group. Start by expanding the property. So inside the toolpath manager, under machine group -1, you'll see properties. You'll see a plus sign to the left of it. Select the plus sign. And underneath properties, you'll see files, tool settings, and stock setup. Let's start by selecting the files underneath property. So inside the toolpath manager, you expand to properties, left click on files. And that'll open up this dialog box. How's everyone doing?
Good.
Nice. Okay. From here, we're going to make some changes to some of the settings. For starters, the group name. This appears right here. We can change the name of it right here. Let's change it to the machine that we plan on running this on. Now, in this class, we're not going to actually run anything on the machines, but if we were at the school and we wanted to run a project, we would probably need some, specify which machine you're going to run it on. So I'm going to call this Haas VF2. We have three Haas VF2s at the school. So group name, we change that. Once you do that, come down to the edit icon. Click on the edit icon. And that opens up another dialog box. On the bottom right side of that dialog box, you'll see mill spindle group. Select the plus sign next to it to expand it, and then keep expanding it. I'm continuing to select the plus sign. Continue expanding it until you see tool spindle. When you see tool spindle, double click on it. And once again, it opens up another dialog box. We want to set our maximum spindle speed to match what our machine is capable of. Our Haas VF2s are capable of 10,000 RPM, so we need to change this value. Set this value to 10,000. So max spindle speed, 10,000, and then select OK. From here, I'll select the green check or OK. And that brings me back to this dialog box. That completes all of the changes that we're going to make on the first page. How's everyone doing up to this point?
Good.
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 Thank you.
Good.
From here, click on the Tool Settings tab. The default program number. This program number will appear at the top of our NC file. That's the file that tells the machine what to do. It's a 4-digit number of your choice. Sometimes it could be a 5-digit number. On the Haas machines, avoid using 9,000 series numbers. So I'm going to randomly select 5,000 in this case. There's a good chance when you work for somebody, they might have a catalog or an Excel spreadsheet where you sign out program numbers. And that way you're not overriding existing programs. So this number, I'm just randomly selecting. So default program number is 5,000. Feed calculation. Let's select from material. Toolpath configuration. I'm going to check assign tool number sequentially. I'm going to check warn of duplicate tool numbers. And I'll check use tools, step, peck, and coolant. Once you check these 3 items, go down to sequence number. These will be the line numbers in our NC file. Once again, the NC file is what communicates to the machine or what tells the machine to do. I want my line numbers to start at 1, and then I want them numbered in increments of 1. Once you do that, we're going to select the material that we're going to machine this part from. Now, the default with this particular machine definition is aluminum inch 2024. If I go back to the project page and I look at the image of the drawing, they're telling us to make this out of aluminum 6061-T6. So let's make that change. Now, there isn't the exact material description in the libraries, but what we'll do is we'll grab one that is close and we'll modify it. So I'm back in Mastercam. Let's start by selecting the material. So select the select icon. From the material list, not much to choose from. We can access the library. So in the blank field, right click, From the flyout menu, select Get from Library. It opens up the material library. Let's select aluminum inch dash 6061. That's something close to what the blueprint is calling out. So select that material and then select OK. It's now added to our material list. You can see that it's highlighted. Select OK again. And that becomes the current material. We're going to make some changes to this material definition. But I'm going to start by selecting the correct material before I make any changes to it. So once we select our material, select Edit. For the name, let's do this. Click in front of the 6061. I'll say aluminum 6061. Then after the one, I'll type in dash T6. And that'll be good for the material name. For the base cutting speed, let's change this to 300. And then for the percentage of the base for drilling operations, let's change the 60% to 50%. To do that, select the 60. So I left click on the 60. It highlights the field. Hit enter. And now you can change the value. So select it, hit enter, type in 50, and then hit enter again. And now the base cutting speed, or the cutting speed for drills, which is 50% of the base cutting speed, is 150. And that's what we want for this class. From here, I'll select OK. That completes all the changes that we need to make on this page. We're now going to move over to the stock setup. Before I move to the next tab or the next page, are there any questions related to what I did here? Okay. So from here, I'll select stock setup. Stock plane, leave it set to top. That should be the default stock plane. Now, what we're doing here is we're going to define what the material is going to look like when we take this program into Verify, or take these tool paths into Verify. So you're not going to understand what this is, what's going on with this just yet, but when we get to Verify, which will be within the next hour or so, you'll understand why we're doing this, or you'll have a better idea of why we're doing this. I want to select a solid model that represents what the material is going to be when we machine the part. Since I created a solid model of the material, for the shape, I'll select solid / mesh, and then I'll select this icon. This will allow me to go back into the graphics area and pick select the model that represents my material. I'll select this icon. The solid that represents my material is not visible. So while I'm in this command, I can access the level manager. I'll make the material level visible. Now I have to be careful. I need to pick select the solid that represents my material. So I'm making the solid model level invisible. This whole time I was making things visible or invisible, it's still prompting me to select the solid that represents my material. Pick select the solid that represents your material. And it brings us back to this page. If everything was done correctly, the values in the X, Y, and the Z should match the dimensions of our material. To check my work, I'm going to select display. I'll select solid, and then I'll select OK. Now it's hard to see because the display is kind of a red meshy. It has a red mesh appearance. If I make my material level invisible, there is, this is hard to visualize, or it's difficult to understand this stage in the game, but this is not a selectable solid. This is just a visual representation of what the material is going to look like when we go into Verify. Once I verify that it's in the correct location, I'll go back to the Toolpaths tab, I'll just toggle off the display of the stock. And I'll also make the solid model level visible again. How's everyone doing?
Good.
Good.
Excuse me.
It says prospect,
I
but
have trouble with the binding box.
Having trouble with the bounding box.
The bounding box, yeah.
The bounding box, when we created the material representation, correct? Can I take control of your screen?
Yeah.
All right, so
Yeah.
hold on one second.
Your candidate can show is collapsed.
So now that we've filled out all of the properties underneath the machine group, I'm going to make one more change to the machine group defaults. Where it says toolpath group 1, I'm going to change that to first operation. To change it, a couple different ways you can do it. You can left click once, left click again. And once it changes to the blue, you can change it. But what I usually do is I just right click on it. From the flyout menu, I'll select groups, and then rename. I'll call this first operation. And I spelled it wrong, so let's do it again. All right, so rename the first operation or the toolpath group 1 to first operation. I'll go back to the project page. And let's see what we've taken care of as far as the instructions are concerned. Step 1, make the toolpaths manager visible and import the machine definition. Did that. Step 2, modify the settings in the machine definition. Did that. Step 3, use the drill toolpath to create the pilots for all through holes on the part. So we're going to use a drilling toolpath, and we're going to use a specific type of tool to create the pilot. And if you go to the bottom of the project page, there is a tool list. Because this is a short program, there are only two tools. Tool 1 in this particular case is going to be a 1/2 inch diameter spot drill, 90-degree DP. This is a drill point angle. And then we're actually going to identify what tool holder we're going to use. We're going to use a C4C3-0032, and we're going to have a 1-inch tool projection. And as I select these tools, select the tool holder, and set the tool projection, I'll point these things out, and it should make a little bit more sense while we're in the process of doing it. So let's go back up here. Something that's missing from these instructions, I want to create a stock model for each operation. And we're actually going to create a stock model for the part prior to any machining. And let's do that right now. So inside the toolpath manager, we have this thing called the insertion arrow. And the toolpaths that we place and the stock models that we create are going to be placed where this red arrow is. It doesn't mean much to us now because there are no toolpaths or stock models in our toolpath manager. So let's do this. Let's start by creating our first stock model. And this stock model will represent what the material is going to look like prior to any machining. Very similar to the bounding box that we use to create the material, or the solid model that represents the material. So from here, toolpaths. In the stock section, select stock model. And that opens up this dialog box. On the very first page, the stock definition page, for the name, call this raw material or raw stock. For the initial stock shape, so what this thing looks like prior to any machining, let's select model. Let's select this icon. We're going to bring back the solid model representation of the material. So go to levels, make the material level visible, and then pick the solid that represents the material. So I'm picking the area where the hole is filled in, so I don't accidentally select the solid model of the part. Once you select it, select end selection. And that's all we'll need to do for this very first stock model. Select OK. And it looks like a gray representation of our raw material. Looks a lot like the solid model that represents the material. So that'll be confusing for the first couple of projects, but it'll make more sense as we get into the more advanced projects. I'll make the material level invisible. You can still see that the holes are filled in because we can still see the stock model. We go back to the toolpath manager, and we have the stock model called raw stock added to our tool list, or added to our first operation toolpath group. To toggle off the visibility of that, you can select this icon right here, toggle display on selected operations. So I know it's a little confusing. We currently have 2 to 3 items in this session of Mastercam that represent our raw material. We have the solid model that represents our raw material. And let me back up. I'll point these things out. So on my screen, we're looking at the solid model that represents our material. They just made it invisible. We also have the stock display for the material that's going to be visible in Verify. We haven't gotten there yet, so just hold on a minute. We also have a stock representation in our toolpath manager, and they all serve different purposes. The solid model that represents the material supports or was used to define the stock model in the toolpath manager and used to define the stock model for display. Or I'm sorry, used to define the stock inside of Verify. A lot going on, so just bear with me. I'm going to toggle off the visibility of the stock model in the toolpath manager. And I'm going to bring back the solid model that represents our part. I'll go back to the toolpath manager. And this would be a good time for me to save my work. So now that I've created the stock model, I can toggle on the visibility of the stock model. I can toggle it off. Once I create it, I like to toggle off the visibility because I can't see what the solid model or what's going on with the solid model when I've got the stock model overlaying it. So once I create it, I verify that it's correct. I'll toggle out the visibility of it. And from here, I think we're ready to start creating our first toolpath. I'll go back to the project page. And we added the step in between step 2 and step 3 where we created the stock model that represents the material. We're going to create a stock model after each toolpath. And the next thing we'll do is we're going to create the pilot up, or the toolpath that creates the pilots for the drill that's going to go all the way through the part. Step 3, use the drill toolpath to create pilots for all through holes on the part. Let's do that. If I go down to the bottom of the project page, tool 1, 1/2-inch diameter spot drill, 90-degree DPA. DPA stands for drill point angle. We've got the tool holder identified, and you're telling us how far the tool is going to stick out of the tool holder. I'll go back to Mastercam. We're going to create our first toolpath. We're going to go to the toolpath tab. This is considered a 2D toolpath, so go to the 2D section and select the drill icon. Left click on it. It opens up a dialog box, and you can see some instructions coming from Mastercam. And it says select one or more entities to add or remove from the features list. So here is the features list. And if something appears in this list or in this field, it's telling Mastercam in this case where to drill a hole. Let's see here. I want to select the circles at the top of the part. We could also select the points that we created, but in this case, I'm going to select the circles. I might have selected the points in the previous videos, but we're going to do a little bit different. We'll accomplish the same thing. This icon right here, it says mask on arc. Select an arc from the graphics window. Mastercam selects the center points of the arcs with matching diameters. Let's try that tool. So I don't have anything in this field yet. I'm selecting this icon, left click. It says select an arc to match. Select the circle that's closest to the origin. So I'm hovering over this circle. You see how it becomes highlighted, indicating that it's going to be selected if I left click on it. Left click. The prompt has changed. It says use window select, Control A or the arc quick mask to find matching arc. So I've got options. I could window select. I could do the Control A option, or I could come over to my selection filters over here. And I like the selection filters. It says, or the quick mask to find matching arcs. This is considered the quick mask, I guess. So on this particular icon, it says select all arc entities. Select the upper left half of this icon. Left click. And you see all of the circles become selected. And then there's a line connecting them. And then I've got this whole list of circles or arcs added to this list. And what we're seeing here is the first point, or the first center point, it's red. That's identifying the very first hole to be drilled. And then you see the following holes that are drilled, and the sequence that they're being drilled in is determined by the lines that connect them. Now, yours might not look like mine. Yours might be in a somewhat different order. That's not a big deal. We can change that, or we can control which holes drilled first and the order that the following holes are drilled in. If you come down to this icon right here, it's a sort selected order. Expand this drop-down menu. And you can see the 2D sort. We've got different options. And the one that I'm going to select is going to be this one right here. It says XZig. Oh, it says XZig plus Y plus. And when I select it, you can see the order has changed. The first hole is still the hole closest to the origin, but you can now see that the holes are being drilled. First, I'm drilling this hole. I move along the X-axis. I move up in the Y. I move back in the X. So that's the way you can control the order that the holes are being drilled in. If I expand this menu again, you'll also notice that each of the options identifies a red point or the start of the drilling pattern. I'm going to stay with the current version that I have selected. And then I'm going to select OK.
Question.
What's that?
I have a question.
Yes, sir.
Is there any rationale to select one or another order?
Oh, okay. So usually it has to
in
do
real life.
with time, like time efficiency. Does that make sense? So let me go back to this. I'll deselect all these. I usually like to identify hole one as the hole that's closest to the origin. And then I like to drill them in the most efficient manner. So let me go back to this version right here. Actually, I need to reselect everything. So I'll select this hole, Control A. Now, this order is relatively efficient, and it's more efficient than, say, this one right here. Here we're drilling 1, 2, 3, 4, and then we jump all the way over to this hole. 5, 6, 7, 8, jump all the way over this hole, 9, 10. See how that works? I would rather take the shortest route to the next hole. And I believe that would save time over a series of many holes. Does that make sense?
Got it. Yeah.
Yeah. So that's the logic behind, you want your programs to be as time efficient as possible. And I'll go back to this method right there.
Cool, thanks.
You're welcome. Okay, so from here, I'll select OK. And that brings up the parameters for this particular toolpath. I've got 16 pieces of geometry driving this toolpath. And on this first page, it says toolpath type. We've already determined the toolpath type when we selected it from this menu here. I'm going to jump down to the tool. And on this page, you'll find your tool list. It's currently empty. Then we have some settings over here, but they don't mean anything until we get a tool in the tool list. To add a tool to the tool list, a couple of different ways you can do it. You could select this icon here, select library tools, or you can you can click in the blank space, this white area, and you'll see this flyout menu become available. And I'm going to select library tool. And that opens up our tool library. Now, there's a good chance yours looks like this. This particular library, there are, let's see here, how many tools? Around 450. And we're looking for one particular tool. So I don't want to have to sit here and scroll through this long list of tools to find one tool. We have a filter that we can use to help us isolate one or two tools. Start by checking filter active. Then select the filter icon. Chances are tool types, they're all selected. If they've got this blue appearance, that means they're selected. Currently I have all tool types selected. Start by selecting none. And then let's find the tool type that we're looking for. We're looking for a spot drill right here. This one's a chamfer mill. They look alike. The graphics look alike, but be careful. This one is a spot drill. If you hover over the icon, you'll see a preview of what the tool title is. So spot drill. I'll select spot drill. We can filter out even more tools. We can filter them out by diameter. So where it says tool diameter, you've got ignore, you've got equal, less than, greater than, between. Let's set it to equal. And on the tool list, they're telling us to use a 1/2 inch or 0.5 diameter 90-degree spot drill. Set the tool diameter equal to 0.5 and then hit enter. So we're looking in the tool library. We're using our filter. We're filtering out everything except spot drills that are equal to 0.5 in diameter. From here, I'll select OK. I've got one tool that matches that description. It's tool 24 coming out of the tool library. And it's a 1/2 inch diameter spot drill. And here's some other information, but take note of the tool number coming out of the library. And I'll go back. I'll actually turn the filter off. You'll notice that each tool has a number assigned to it while it's in the library. Here's our tool right there, 24. Turn my filter back on. Watch what happens to the tool number when I add it to my tool list. Double click on it. It's added to my tool list as tool number 1. Reason being is when we were back in our tool settings over here, we checked assign tool numbers sequentially. And the reason we do that is so that the tools come in to our tool list in sequence. They're not always going to be in sequence, but a lot of times that tool setting will help us out quite a bit. One thing it will prevent from happening is a tool coming in with a number that's greater than, say, what your machine is capable of. There are some tools that I think we had up to 450 tools in that library. If you did not have that set, when you double clicked on the tool, it'd be added to our tool list with whatever number it was assigned to coming out of the library. So tool number 1, first tool in our tool list. Under tool settings, I had assigned tool number sequentially checked. From here, we're going to make some changes to the default settings of this tool. Right click on the tool, select edit tool. One second, please. Okay, so we're gonna edit the default settings to this 1/2 inch diameter spot drill. And to revisit how I got here. Under the parameters for the tool in the tool list, I've added this tool to my tool list. Right click from the flyout menu, select edit tool. A few things that I'm going to change on this page. I'm going to start by changing the cutting length. On a spot drill, the cutting length isn't going to be much more than the length of the drill tip. So let's set the cutting length to 0.25. And you can see that the cutting length is designated by this yellow shade. And let's set the shoulder length to 1.5. That'll complete all the changes that we need to make to this page. From here, I'll select next. On this page, we're going to change a few things. Number of flutes. To get Mastercam to calculate the feed rates correctly, we need to set the number of flutes to 1. How Mastercam is going to calculate the feed rate is going to be based off the feed per revolution. So we need to set the number of flutes to 1. So it calculates based off of a feed per revolution. It's not like an end mill, which is a feed per tooth. So set the number of flutes to 1. To calculate the RPM or to have Mastercam calculate the RPM, select the calculator. Mine is being calculated at 1,146. We can also turn the coolant on. It's a water soluble cutting fluid, and it'll help lubricate the tool, help keep the tool cool, and it'll also help evacuate chips. So I'll expand this menu. I'll select show more options. I'll select the coolant. And then where it says flood, set this to on. This will generate an M8 code inside of our NC file, turning the flood coolant to on. I'll select OK. And that will complete all of the changes that we need to make to this page. I'll select finish. And that brings us back to this page. In this section, you'll see the spindle speed. This is the RPM or the speed that the tool is rotating, 1,146, and it's based off of this 150 SFM. The feed rate, which is controlled by this FPT, it's FPT multiplied by the RPM. But because it's a drill, I want you to think of the FPT as an FPR, feed per revolution. I want to set my FPR equal to 2% of the tool diameter. To do that, in the FPT field, think of it as FPR, type in the decimal equivalent of the tool, 0.5, and then multiply it by 0.02, 2% times 0.02, and hit enter. It updates this field. So for every revolution of the tool, it's going to move 0.01 inches into the material or through the material. And the feed rate expressed in inches per minute will be 11.46. That will complete all the changes that we need to make to this section.
Does that have to do with the chip load?
Yep. So think of the FPT as feed per tooth or chip load per tooth. And with drills, think of it as FPR, feed per revolution. And as each rotation, as the tool rotates once, it's going to move this far through the material. And if we're moving at 1,146 rotations per minute, it's going to move through the material at 11.46 inches per minute. So these two, or this multiplied by this, gives us that. Does that make sense?
Yes.
Yeah, so this is the amount of material, or this is the distance that the drill is traveling through the material per revolution.
Okay.
Okay, so from here, here's a comment field. We can provide some type of useful information to the operator, to the setup guy inside of the program. And at each tool change, or at each operation, I like to provide some type of useful information. So I'll start by taking the tool name. I'll paste it down here. And then let's say drill and enter this in all caps. Drill all pilot holes. And that will complete all the changes that we need to make on this page. From here, go to the holder. Now, on the project page, we're instructed to use a C4 C3-0032 tool holder. That is a Cat 40 ER32 tool holder. It resides somewhere in this long list of tool holders. Instead of looking through this long list, we can isolate which library we're looking at. If I select Open Library, it takes us to the tool holder library, or tools and tool holders. I'm looking for the Cat 40-inch tool holder library. So CT40-IN. So Cat 40-inch, select it. Select Open. And that reduces the tools that that reduces the type of tool, or limits the type of tools that are visible in this list. And now I'm not only looking at Cat 40 tool holders. I'm looking for a C4 C3-0032. So it's Cat 40 ER32 is a collider type tool holder. Looks like you see here. And then let's set our tool projection. What are we instructed to do? Set your tool projection to 1.5 inches. So that's going to insert the tool deeper into the collet. So tool projection, set that to 1.5. Enter. And that's a pretty realistic representation of what we might see out at the machine. And that'll complete all the changes that we're going to make on this page. How's everyone doing?
Good.
Hi, could you mind show me again the change of the tool path type? The first one?
Tool path type
Yeah, the first one.
up here.
Yeah.
So it's a drill right there, drilling type tool path. I'm not quite sure what you want me to do.
Because I saw the geometry of you is like 16.
Yes,
And and the drill of mine right now is like 28. So
28. Okay, so
yeah.
may I take a look at your screen, sir?
All right.
Okay, let me stop sharing my screen. Okay, so you got 28. I'm gonna take, so do me a favor, go to click on the deselect. So far right, upper right corner of your screen.
Alright.
Down a little bit. Next to the 28, I want you to click on the one over.
One over.
One over. So one icon over, go over. Right there, yes.
Right here.
Yep.
Okay.
Now I want you to select the cursor icon again.
This one.
Yep. Now I want you to use the mask to the left. There's a field, go down a little bit. Right, yes, that one. I want you to select the circle closest to the origin. Oh, I see what's going on here. Hold on, back up. Go back to your level manager. You've got your solid support geometry level visible. Or maybe not. Wireframe from solid name. You shouldn't have, maybe that's right. Okay, so go back to your toolpath manager. And select an arc to match. So select one of the circles on the top. Yep, just one. Now Control A.
Control A.
So you got 16 entities selected. Perfect. You're missing a dialog box. Oh, so the bottom left corner of your screen, you need to maximize bottom left corner. See where it says 2D toolpaths at the bottom left corner of your screen. Bottom left corner,
All right.
bottom left, yes.
So-
Don't close out. I'm gonna take control of your screen, okay?
All right.
Okay, so there we go. Hold on. All right, let's see here. Okay, so we got 16 entities. That all looks good. Green check. Regenerate. There were one or more errors in the warning. Unable to calculate toolpath, tool assigned. Tool operator does not exist. Okay. Oh, you don't have a tool. So now parameters. Tool. There's your tool. Oh, my bad. 0.5 times 0.02. So you're pretty much where I'm at. You're gonna add a description down here, but for now, holder, you got all that, you're good. So you're right where I'm at. So I'm gonna give you control of your screen. So you got 16 entities
All right.
and you're probably gonna have to regenerate it and hit, I'll show you what to hit here in a moment. All right, so back to my screen. Okay, so I've got my tool holder selected. I'm gonna go to cut parameters.
I have a question.
Yes, sir.
So what we're doing is we're configuring the tools to do, like, to operate on these parameters, or we are configuring the software to the parameters that the tool is set up. or that the-
I didn't understand any of that. I apologize.
Sorry. So-
Um,
Like if you go back to tool or the tool holder.
mhm.
So when we select a tool holder here,
Yes,
so we are saying this is what the machine has and we need to select that holder.
correct. So this is, you're gonna have to select the tool holders that are available to you in your shop. So I've, at where I work, I have a bunch of CAD 40 ER32 tool holders. These are Collida type tool holders. There are some other ones that we're using. So when we're on the project page, I'm instructing you to use a specific type of tool and tool holder with a specific tool projection. Does that make sense?
Like, for example, the tool projection is also is given.
Yeah, so I'm giving, if you look at, can you see my screen?
Yep.
Yeah, so I'm giving you some information to clarify what you're instructed to do. Otherwise, we could spend a lot of time just trying to figure out or find tools. And I'm sure there are several students here that work in different locations and they use different type tool holders. We're just using a common set of tool holders and common set of tools that you would find in most shops.
Got it.
All right. So yeah, so here we have the C4C3-0032. I set my tool projection. Now there's a lot of things here that we don't need to adjust. There's a lot of bells and whistles. I don't use most of these majority of the time. I use maybe 5 or 6 of these items within each toolpath parameter. I'm going to jump down to cut parameters. And the cycle is set to drill / counterbore. Dwell is 0. So this is going to create a G81 drilling cycle inside of our NC program. And I'm just checking this. This is the default. Once again, we selected use tool step peck and coolant. So that's a standard, it's a standard setting inside of Mastercam based off of that selection that we made under tool settings. From here, we're going to jump down to linking parameters. Now, these linking parameters are based off of Z0 or the geometry that's driving the toolpath. If it's absolute, it's based off of Z0. If it's incremental, it's based off of the geometry that's driving the toolpath. We'll talk about that more in depth at a later date. As a default, let's set our clearance 2 inches absolute. So relative to the origin, this is 2 inches above the top of the part. And I'm going to check use clearance only at the start and the end of the operation. For the retract, I've got it set to incremental. So this is relative to the geometry that we selected. Set this to 0.1. Top of the stock, I'm going to set it to absolute. The origin is sitting on the top of our part. So top of stock, 0 absolute. And then for the depth, I'm going to set it to absolute. And then I'm going to use the depth calculator. Because this is a spot drill, I like to use the depth calculator. So I'll select the calculator. We're going to create a pilot. And what I mean by a pilot, it's a conical profile left by the drill. The diameter of the profile is going to be equal to the diameter of the hole that's being drilled in the part. I don't want to drill too deep because I can make a countersink, or I can make the hole out of tolerance. I'm going to set my finish diameter equal to the hole diameter, 0.201. I could make it smaller, but I don't want to make it any larger than the finish diameter of the hole. I'm going to select overwrite depth, and then I'll select OK. And it's going to drill to a depth of Z minus 0.1005 to create a 0.201 diameter countersink diameter. From here, make sure tip comp is turned off. See that circle with the diagonal line to it, the red circle with the red diagonal line? That's an indicator that tip comp is turned off. And that'll complete all the changes that we need to make to this toolpath. I'll select OK. There's a good chance you might need to select the regenerate all selected operations. So select this icon. And right away, I'm seeing a preview of what this toolpath will look like. And what we're seeing on the screen, we're seeing a series of lines. They're yellow, they're blue. The yellow lines represent the center line of the tool, and they also represent rapid moves. And then the blue lines, once again, it's the center line of the tool, and it represents a feed rate move or a G1 move. And actually not G1 move, but it's a feed move inside of a G81 drilling cycle. So this is what our toolpath is going to look like. To actually watch an animation of what the tool is going to do with this toolpath selected, you see the green check next to my toolpath? With this toolpath selected, we're going to select this icon right here. It says backplot selected operations. I select this icon. You see a tool become visible on your screen. And I got two separate groups of controls appearing on my screen. I've got my play controls, and then I've got my visible control or my backplot controls, and I can toggle on the visibility of certain components. If I make the tool holder visible, or tool, oh, there we go. There's my tool holder. There's my tool. And there are my rapid moves, or display rapid moves. Okay. To play it in backplot, I can control the speed with this slide bar. I've got play, I've got stop, previous stop, step back, step forward, next stop, and then I've got trace mode and I've got run mode. I don't use the majority of these. Majority of I use play and the speed. And it gives us an idea of what the toolpath is going to look like. And things that we can look for while it's running in backplot, looking for the tool, not retracting far enough, the tool doing a rapid move through material. So things like that you want to catch before you send the program out to the machine. I can also back up by hitting the B key. So I'm just holding the B key down or hitting or single stepping through it by hitting the B key. You can also do that with the S key. You can step forward. I'm just hitting the S key. And it's like single step in the program. So hit the play button, it'll run out. And I like what I see in backplot. I'm not seeing any problems. Nothing's obvious to me. So I'll close out of backplot. I'll select this X right here. I can toggle off the visibility of the toolpath. It's like the stock model. This icon right here toggles on the visibility or toggles it off. Toolpaths works just like the stock model. So they're still there. But you see how this icon changes its appearance? That's when it's visible. That's when it's invisible. And the stock models function in a similar way as far as visibility is concerned. So I've created my first toolpath and I ran it in backplot. And I'm looking for any type of error that might occur while it's at the machine.
Question?
Yes, sir.
Sorry,
No problem.
I have to, like, everything looks good on mine except they have these like dotted circle lines above each of the.
Got it. So let me show you what that is. You see this quick verify? It actually might be. Oh, that's a different one. That's down there. And I wonder if it's the version of the software that you're working with.
Possibly how do you get to that back menu?
Okay, so if you go to this icon right here,
Huh?
and if I hit the play button,
Yeah.
I'm not seeing anything because I don't have my tool holder, my tool, my rapid moves. I do have that select. That's not doing me any good. There's options here.
Oh.
Yeah, there's some settings here, and I know what you're talking about. I just can't remember when I
It's not-
turned that off.
It's not a big deal. It's just a reference.
Yeah, it's
Okay.
just it's nothing that's gonna create the same NC file. I can research that. Maybe we can, because somehow I've turned mine off, and I remember seeing that in previous, the current version and previous versions of the software. It's something that I turn off and I forget about.
So like if it's a dotted line, it's not that big of a. I mean, it's just a reference.
Does it mean show endpoints?
This one right here,
Yeah, yeah.
I had that turned on. No, he's seeing big circles at the
Yeah, I
top
think-
of his toolpath. Am I correct when I say that?
Yeah, let me just share real fast. Just
Yeah,
to see.
I'll show you. Yeah, so we'll keep an eye out for it. So yeah, those. It's something really simple. I just can't. It's. If you turn off the display, just toggle off the display of that toolpath, it goes away. No, not there, not there. So far left corner, it's just when we toggle off one down, one over. That one. Yeah, see, that gets rid of it. It's those dashed lines, those dashed circles. And I've seen them before. I just can't remember what causes them. I didn't care for them, so I turned them off. But it sounds like a lot of other people are not getting that same issue as you.
Yeah, I just
I got the same issue as well.
Okay, let me research that. And Corey, are you out there? He might know the solution to that problem. Doesn't sound like he's readily available. So what we'll do, give me a day, and I'll research that for you, and I'll come up with a solution for it. I don't care to have those circles visible, to be honest with you. And it's not, it's probably something under configuration.
Mhm.
If I go to configuration and let's see here, simulation, backplot. Yeah, it's a setting somewhere. So I'll have to look that one up for you. Okay, so outside of that, is everyone good? So that's one level, or what is, you can visually inspect the toolpath inside of backplot. You can actually run backplot and see an animation of it. And you're looking for things that would cause a problem when it's actually at the machine. Tool rapiding through the part, rapiding into the part, drilling too deep, cutting too deep, tools moving through the material where it shouldn't be. Those are things that I'm looking for inside of backplot. That's
And do we
one.
know, question,
What's
how do we know if like it's drilling too fast? Like how can we tell that?
inside of backplot, you can't. That's something that if you're at the machine, you're going to check your speeds and feeds. You're going to go with the recommended RPM and the recommended feed rates that the tool manufacturer recommends, or you're going to look it up on the internet or in the machinery's handbook. If it's if the chips are too thick, that could be a problem. You're going to cause a tool to wear out or break. If they're too thin, they're going to build up on the tool and wrap around the tool, preventing the coolant from getting to the cutting edge. So there's a lot of variables involved. Types of material, certain types of materials are stringier than others. Chip control, that's a whole nother concept. For in this class, we got some basic cutting speeds that we're going to use, and it's more about learning the software. But as far as cutting speeds and feed rates, reference the tool manufacturer's website or the literature that comes with the tool. Does that make sense?
Yeah, makes sense. Thanks.
All right, you're welcome. Okay, so from here, I want to take it to the next level of verification. Before we do that, I highly recommend that you save your work. Save your work frequently. You don't want to lose your work. If you got some time invested in a project, protect your work. So from here, I'll go File, Save. With my toolpath selected, and you can select the entire toolpath group, and that'll put a green check next to everything within the toolpath group. We're going to go to the icon that's next to backplot. Select this icon, and that will open up Verify.
Sorry, what icon again?
What was that?
What icon again to verify?
Okay, so the icon next to backplot. If you hover over it, it says Verify Selected Operations.
Gotcha.
And it's going to open up another window. It's going to look very similar to your graphics inside of Mastercam, but there'll be some different tools that we can use.
Copy.
So on my screen, you see Verify opened up, and I maximize my screen. And you can see there's a shaded version of the part. There's a shaded version of the tool holder and the tool. And if there's going to be a collision, if the tool rapids into the part or rapids through the part, it's going to give us a warning. Or if in certain cases, if the tool holder hits the part, it will give us a warning. For us to take advantage of that option, we want to go to the Home tab inside of Verify. And where it says Stop Conditions, expand this menu, and then select Collision. Then you'll see a check appear next to Collision. And every time I go into Verify, I always make sure that the collision is selected. This is the reason why I run it in Verify. I'm checking for a crash. I'm going to slow it down. So on the bottom of the screen inside of Verify, you'll see some controls. I've got a slide bar to control the speed on these drilling operations. It'll go pretty quick. So I'm going to slow it down so we can kind of see what's going on. For the precision, this will make for a smoother machined model inside of Verify, but it will slow your computer down. So be careful when you adjust these settings. And if you hit the play button, it'll just run right through. You can single step with, let's see, one of these icons. So there's next operation, or there is step forward. And the step forward is like hitting single step on your machine. You can also hit the S key and accomplish the same thing. And I'm rolling my scroll wheel in and out to zoom in and out. And you can see it's working away. It's following the toolpath or the order that we told it to drill in. And it's creating a pilot, a conical shape. You know, it's the profile of the 90-degree spot drill. And the diameter of that shape is equal to the diameter of the hole that's going to be drilled in the part. You could make these pilots a little bit smaller in diameter, but I wouldn't make it any larger than the diameter of the hole that's being drilled in the part. So I'm just hitting the S key and stepping through it. When it's all said and done, I'll inspect the model. Everything appears to be good. I can see the wireframe representation of the part overlaying the model. And if these pilots were too large, it'd be noticeable inside of Verify. So this all looks good to me. I don't have any collisions. So from here, I can exit Verify. And it's not a bad idea to save my work again. So now we verified that the first toolpath is correct. I want to make a stock model that reflects what that first operation or what that first toolpath has done. You'll now notice that I have a stock model and a toolpath inside of my toolpath manager. The red arrow, we'll refer to that as the insertion arrow. That can be repositioned if you need it to be, if you need to insert something between existing toolpaths or existing stock models, you can reposition that insertion arrow with these icons, or you could drag it. I prefer to use these arrows, a little bit more control for me. Be aware of where this is located when you create stock models and when you create toolpaths, because sometimes you'll create things in the wrong place if you're not aware of where this is positioned. So I've got my insertion arrow at the very end of my toolpath group. I'm now going to go to the toolpaths tab, stock, in the stock section, and I'll select stock model. For the name, let's call this one pilot holes. And then for the initial stock shape, I'm actually going to use the stock model that we created that represents our raw stock. So for the initial stock shape, I'll select stock model. And from this drop-down menu, the only other stock model that's available right now is the one that we created that represents the material. So stock model, raw stock. That'll complete all the changes that we need to make on this page. And then go to source operations. It's going to show us everything that's available inside of our toolpath manager or in toolpath group 1. Select the drilling operation that we just created. And once you do that, select OK. Now it's going to take a moment to process. And when it's done, you should see a stock model now that shows the pilot holes drilled into it. And if it's difficult to see, just go back to your level manager. You can toggle off the solid model level. And this gray shaded representation of our part, this is the stock model. And it has the pilot holes drilled into it. And the nice thing about these stock models is they're dependent on the toolpaths. So if I go back to the toolpath and make a change to it, the stock model will update and reflect what the toolpath has done. Don't do this. I'm just going to show you a quick example of the relationship between the source operation and the stock model. So if I go to the parameters here and I go to the linking parameters and I change this to -0.15, deeper than it needs to be. I'll select OK. You'll see that this one has a red X next to it, and this one has a red X next to it. I'll select regenerate all dirty operations. And without running it in backplot, without running it in verify, you can see that the stock model is showing us what the pilots look like now. And that is much too large. That is not going to work for us. If we drill that deep, we would scrap the part. So the reason I did that was I wanted to show you the relationship between the stock model and the source operation, which happens to be this drilling operation. So if I saw something like that inside of Mastercam, I would want to investigate what's going on with this, because that is not correct. Go back to the parameters of the source operation, change this back to 005, select OK. Once again, I made a change to this drilling operation, and because this one is dependent on it, I've got a red X next to both of them. I want to select regenerate all dirty operations. And what it means by dirty is that it needs to be regenerated. It has a red X next to it. So regenerate all dirty operations. You'll see the stock model update, and it now shows us the latest or the current depth of the pilots. And you can see, I'm inspecting it, I'm comparing it to the wireframe representation of the part. They appear to be correct. So once I verify that the stock model is correct, I can toggle off the display, select this icon, and it disappears. I'll go back to the level manager, and I'll make the solid model level visible again. So that's how we're going to use stock models at this level. Further down the road, you can actually use them to tell Mastercam how much material is left over on a part between operations. They can drive toolpaths as far as telling Mastercam where it needs to go and remove material. So they're very powerful. We're just getting introduced to them at this level. In the later classes, we're going to use them for other things. So from here, I need to create one more toolpath. It's another drilling operation. Now we could copy and paste the existing one, make a few changes to it. But at this stage, I think it's beneficial that we just go through the whole process of creating the toolpath, identifying the tool, and then setting the different setting the different parameters. So I'm going to create another drilling operation. I'm going to go to the toolpath tab. In the 2D section, once again, I'm going to select the drilling toolpath or drill, left click. Brings us back to this dialog box. I'm going to start by selecting this icon, mask on arc. It says select an arc to match. I'm going to select this arc here. It's now saying select additional circles or additional arcs. You could use the window selection, you could use Control A, or you can use the arc quick mask. In this particular case, I'm going to window select. I'll position my cursor here, left click, and drag my mouse. I want to make sure that the window captures all of the circles that I want to draw. Left click again. You can see that 16 circles have been added to this list. I'll scroll down here, and I don't need to make any other changes. I'll select OK. So there's 16 pieces of geometry driving this toolpath. From here, I'll go to the tool. You can see our tool list. It's got one tool in it. This tool is currently being used by the other toolpath. We're going to add another tool to our tool list. I'll select the select library tool icon here. It brings up our tool library, and you can see that the filter is still active. I'm only seeing that tool, that half-inch diameter spot drill that we filtered out the last time we selected a tool. So what I'll do here is I'll select filter. I'll deselect the spot drill, and I'm going to select drill. And for the tool diameter, if I set it to ignore. It's going to show me every tool, every drill coming out of that library. So what I can do is I set it to equal. And then if you know the decimal equivalent of the tool diameter, or even if you know the fractional version of it, or in this case, if I know the number, the wire size of the drill, I could enter it in this field. If it was a 1/4 inch, I could type in 1 divided by 4. It'll do the conversion for me. If I know the decimal equivalent, I could type that in. Or if I know the letter size or the wire size. This is a number 7 drill, considered a wire size. If I type in #7 and hit enter, it shows me the decimal equivalent of a number 7 drill. And that works for all wire size and all letter size. If I typed in #X for the letter X drill, it's going to come up 0.397. F drill, 0.257. So in this particular case, it's a number 7 drill. I could type in 0.201, or I could type in #7 and hit enter. From here, I'll select OK. There's one tool that fits that description. It's tool number 110 coming out of the library. I'm going to add that to my tool list. I'll double click on it. It's added to my tool list as tool number 2. I'll need to make some changes to the default settings of that tool. Right click on the tool, select edit tool. On the first page, I'm going to make a few changes. I'm going to set the cut length to 1.5. And I'll set the shoulder length to 2. And that'll allow us to set our tool projection to 2. It'll only let us hold on to the dark gray. It doesn't let us hold on to the light gray or the yellow. So that's why I'm changing the tool length and the cutting length. I'm sorry, shoulder length and cutting length. From here, I'll select next. Once again, I'll set the number of flutes to 1. I want Mastercam to calculate the feed rate based off the feed per revolution. I'll select the calculator to calculate the RPM. It's based off of 150 SFM, surface feet per minute. To turn on the coolant, I'll select show more options. I'll select coolant. And then I'll set the flood coolant to on. And then I'll select OK.
Question.
Yes, sir.
I think I might have missed it, but you set the SFM earlier for the material that we're working on?
Mhm.
Okay,
That was set back under the tool settings.
okay, got it. Thank you.
You're welcome. Okay, so from here, I turn on the coolant. I'll select finish. And that brings us to this page. Now the RPM has already been calculated. You can see how it's set it to, or it's calculated from 150 SFM. Now this is a, it doesn't round up. So if I change this to 150, you see how it doesn't affect this all that much. If I change it to 228.51, you see how this is interactive. It's actually 2851. So it's calculated roughly at 150 SFM. For the feed rate, we're going to set the FPT, think of it as FPR when you use a drill, to 2% of the tool diameter. The decimal equivalent of the tool diameter is up here, so 0.201. I meant to select down here, so 0.201 times 0.02. I hit enter. And it's calculating my feed rate at 11.457, almost 11.46. From here, provide some type of comment. I'll borrow the tool name. I'll paste it down here. and provide some type of information. We'll say drill holes through. And any information that goes into the comment field, type it in as all caps because that's what it's going to get converted to anyway at the controller. So that'll complete all of the changes that we need to make on this page. From here, I'm going to go to the holder. Go back to the project page. And if you look at the tool list, it's saying tool number 2 is a number 7 drill, 0.201 in diameter, 0.201 in diameter, 118-degree DPA drill point angle. The tool holder is going to be the same as the first tool path, C4C3-0032. The tool projection is going to change, though. It's going to be 2-inch tool projection. So instead of looking through this long list, I'm going to look in a different library. So I'll select Open Library, Cat 40-inch. I'll open it up. And we're looking for a C4C3-0032. Set the tool projection to 2. And that will complete all of the changes on this page. From here, go to cut parameters. This time Mastercam has changed over to a PEC drill cycle. This will create a G83 drilling cycle inside of our NC file. The PEC increment or the Q value will be around 60 thousandths of an inch. This value is equal to the drill tip length based off of the DPA. That's a Mastercam default. From here, let's go down to linking parameters. And you'll notice inside of Mastercam, when you use similar tool paths, the following tool paths will hold on to settings from the previous tool path. So you'll notice that the clearance is already set to 2 inches absolute. Use clearance only at the start of the end of the operation is checked. The retract is 0.1 incremental. Once again, this is carrying over from the previous operation. Top of the stock is 0 absolute. The depth, I've got to set to absolute. This drill is going all the way through the part. So when I identify the depth, I can select this icon right here. If I select depth, it allows me to go back into the graphics area and pick select something on the part that I can use to define the depth that I'm drilling to. So in this case, I'm going to lock on to something that represents the bottom of the part. And you can see that the Z value relative to the origin is placed in this field. So Z is negative 0.11 or 188. And this is telling the machine how deep to drill to. Now, if I drill to a depth of Z minus 0.188, the hole isn't going to go all the way through the part. The tip might slightly break through, but I need a full diameter going all the way through the part. What I'm going to do is I'm going to turn on a thing called tip comp. So underneath linking parameters, I'll turn on tip comp. Select the checkbox next to it. This graphic pretty much explains what we're trying to do. I want the full diameter of the drill to go all the way through the part. I want it to break through the bottom of the part by a certain amount to guarantee that I get a full diameter going all the way through the part. So let's set the breakthrough amount 0.025. And then the tip length, the additional distance that it's going to travel to accommodate or to compensate for the tip length, is right here. And it's based off of this 118-degree DPA. Now you'll find in shops that they have different drill point angles. There are 135s, there's 140s. If you're using a drill with a different drill point angle, you're going to want to specify that here. And then it will calculate a different tip length. In this case, we're using 118, so this will work. From here, everything should be good. I'll select OK. Once again, I can see what the toolpath is going to look like. This one's a little bit different. You can see the blue lines going well beyond the bottom of the part. If I select the toolpath, I've got a green check next to it. I can run it in backplot. And I've got these points visible. I don't want those. Now this is a peck drill cycle. So it's going to drill a specified amount, retract, fast rapid back to where it left off and continue doing that until it gets to the final Z depth. It looks something like this. I'm not seeing any issues inside of backplot. So I'll exit backplot. I'll toggle off the display of that particular toolpath. I'll look at it from an isometric view. I can fit my screen and I can unzoom by 80%. Before I go into verify, I would like to save my work. So I'll go to File, Save. I'm going to run the entire toolpath group inside of verify. So I'll select the first operation toolpath group. You'll see green checks appear next to everything. From here, I'll select verify. It opens up verify. Once again, inside of verify, make sure that stop condition collision is turned on. I could slow it down a little bit. I could maximize the precision. Once again, be careful with the precision. It will slow your computer down. And then I'll select play. So we're creating our pilots. And then we're going to come in with this 0.201 diameter drill and drill all the way through the part.
Why does it goes multiple times?
It's called a peck drill cycle. So, or also known as a deep drill hole cycle or deep hole drilling cycle. What it does is, on this particular part, you probably wouldn't even need to use the G83 drilling cycle. But let's say we were drilling 2 inches into a piece of material. We might want to retract the tool, let the coolant lubricate the cutting edge, cool off the tool, then it rapids back to where it left off, and then it continues for a specified amount. Does that make sense?
It makes sense. So did we specify that, or is it just the software?
That's a default. It's a default inside of Mastercam, and I'll show you where I found that. So when we told it to use, remember that checkbox, use tools, step, peck, and coolant. So when it uses a pilot drill or a spot drill, it's going to default to a G81 drilling cycle. When we select a regular type drill, or what's referred to as a jobber drill, it's going to default to a G83. So this looks good inside of verify. I don't have any collisions. So let me exit verify real quick, and I'll show you where the difference between those two. So here's a peck drill, and here's just a common drilling cycle. So when I go into the parameters, under cut parameters, see how it says peck drill right here?
Yeah.
I could change it if I wanted to, but I'm going to go with what Mastercam decided. And then over here, this one's just a common drilling cycle. So if it's a drill forward / counterbore drilling cycle with no value here, it's going to create the drilling cycle, G81. If I put a dwell value here, and this is a conversation for later, if I put a dwell value here, it's going to use the counterbore drilling cycle. And that's going to create a G82, and it's going to have a dwell value specified somewhere in that drilling cycle. So G81, and then we have a G83. All right.
Oh, thanks.
All right, cool. So we've just created the second toolpath and the final toolpath for this project. We still need to create the stock model and several supporting files, and we'll do that with our next session.